Good morning to everybody online. Welcome to the briefing. We're just waiting a couple of minutes, bear with us while people filter in and take their seats, and we'll commence very shortly. Oh. That again. Good morning, everybody. Welcome online. Welcome to the market briefing. We'll be commencing very shortly. People are filtering to the room and taking their seats. So if you just bear with us a couple of minutes, we'll get going. Good morning, everybody, and good morning again to people joining us online. My name is Jason Bennett, and I'm the Director of Salvage Services at ABL, and it's my pleasure to host you today for this month's market briefing. Our briefing this morning is accredited to the Chartered Insurance Institute, and delegates can claim up to 1 hour's CPD for your participation. We will therefore keep a record of those of you attending in the room today, and for those online, we'll keep your record as well. If you have not done so already and you're present here in the room, please make sure you sign in with the team at the desk you just passed on the outside after the briefing, and they will make sure that you do receive an email with a CPD certification. I'm delighted to introduce our technical presenters today, of which we have two. Tim is a marine engineer. He sailed from cadet to first engineer with Shell and came ashore, where he was superintendent and technical manager for large ships and ship managers and ship owners. His experience in most ship types. He does specialize with a focus on tankers, but also has experience with ice-classed vessels. Our second presenter is Cindy, and she'll be presenting this month's case reports. Cindy is a consultant electrical engineer who has recently joined the London office from our New York branch. Welcome to London. She mainly focuses on engineering for offshore wind and renewable industries. The usual rules apply. Chatham House rules. So the contents can be talked about, but not accredited either directly or indirectly from this place. And also, bearing in mind I'm speaking as well, but also for everybody, the opinions, if they are expressed, information contained, are the opinions of the presenters and not necessarily ABL. Morning. I would ask that after the presentation, could we take time, please, 3 minutes, should take only, to complete the online survey. It really is critical to us. We need that to keep going for the CPD points and the accredited status. And it does allow us to continue offering you CPD points for attending these briefings. So please, if we can have just a few minutes of your time afterwards, please complete the questionnaire. It does also, of course, mean that we can actively look for improvements for these briefings and to match your requirements and best fit what you need as the situation changes. Please use the QR code on your screens, or for those present here, you can find them outside room on the desk you passed. And we'll also send you it in a follow-up email. Before I do hand over and the technical side commences, we start to give a few moments thought to the Neptune Declaration. There are a multitude of factors at present in the world which impact adversely on the lives and conditions of seafarers, of which I was one years ago. It has changed, and conditions are probably even tougher than when I was at sea. They include working often longer hours or longer durations than they're meant to due to crew change issues. Many of our colleagues, as I said, are seafarers, have seafaring background, including Tim. So crew welfare is very much a cause close to our hearts. As such, we are a signatory to the Neptune Declaration, which has undoubtedly played a part in recent improvements. Please take a moment to look into this, if you would, and perhaps consider getting your own organization or company to become a signatory. Tim, over to you.
Different head shape problems. Morning, everyone. So I was asked to come and present a small kind of introduction briefing to LNG vessels and their challenges. It's fairly basic level. Just kind of cover a broad spectrum of kind of interest, predominantly because obviously there's a lot of people here with different backgrounds and things, and as we'll see, a lot of kind of the more interesting things are very difficult to talk about in context of LNG vessels. So today, the learning is to target anyway, hopefully, be able to explain the operation of the LNG vessels, understand the fundamental principles and the different types of LNG vessels, gain an understanding of the operational constraints of these kind of vessels and the challenges when we think about them in relation to other vessels. And then also at the end, we'll have a look at some of the kind of common claims that we see or expect to see from LNG vessels. And then we'll run through them at the end and see if we've achieved all this. So the LNG world is a bit of a, like all shipping sectors, I guess. They love acronyms. They love terminology that no one else likes to understand because it makes us sound like we know what we're talking about sometimes by using acronyms. So in the LNG world, there's a few more common ones, which if you're involved or talk about LNG vessels or you get involved in a conversation about LNG vessels that you'll come across that are perhaps different to other kind of vessel types. So the first one is vessel size. LNG vessels, for some unknown reason, historically, always refer to the cubic capacity or the cargo capacity as opposed to a tonnage. That's predominantly due to the kind of cargo. It changes very little in its composition. So a cubic meter is a much more easy way as opposed to a ton of measuring the cargo. A ton being, as compared to a tanker or a liquid cargo vessel, a less useful method of measuring. Cool down. So LNG vessels, we'll come more into this later. LNG is a cryogenic cargo. It has to be cooled down. We can't just take that into a tank down to minus 160 degrees from 20 degrees outside. We have to keep the vessel cold. We have to cool it down. So cool down is basically when we transition the vessel tanks from whatever condition they're in down to the loading condition to take the cargo on board. Heel is another one, which is a favorite of people in LNG that they like to talk about. It's something that is not entirely understood, particularly in a commercial sense, sometimes by cargo brokers or those people fixing the vessels. So heel is something that over the years has changed a little bit in LNG. Traditionally, an LNG ship would go from point A to point B, and that cargo was often controlled and owned by the people who owned the terminal at one end or the other. So the cargo never really left the ship. It would load a cargo and it would leave a portion of the cargo in the tanks to keep the tanks cold for the next time the ship got back to load. As the world's changed and LNG trading has changed, heel is much more critical, because if you buy a cargo from me, you want all of that cargo. You don't want me to keep any in my tanks so that I can load it for someone else next week. So heel is something that nowadays is much more problematic for those people operating the vessels, because ultimately, if I discharge all my cargo today to you as the receiver, and I then sail my ship from the UK back to Norway to go and load a new cargo, for instance, I still need to then cool down my ship again. So where do I get that liquid back from? That's the heel portion of the cargo. And commercially, that can be quite tricky. It can be quite tricky to arrange because of the process. The next one is boil off. So as I said, LNG is a cold cargo. And at the temperature and the pressure that it's carried at, it continuously boils. It continuously receives heat inside from the external environment. And when it boils off, it generates cargo vapor. So the boil off is something which some of you will be perhaps familiar with or have been involved with in a commercial kind of cargo claim sense, where, you know, a ship will be warranted to have a specific boil off value. And when the ship goes and discharges or over a few voyages, it's actually lost more cargo than it should have done. It's quite a common area of sort of contractual difficulties, particularly with new build yards. Sloshing, this is a favorite, and actually a couple of people over the last few days while I've been in London, we've already kind of talked about this kind of things, and we'll talk about it further in the presentation. Sloshing is, it's quite a good term, I suppose, but basically it's the movement of the cargo inside the tanks. So all liquid cargoes, if you carry a glass of water and move it a little bit, that's sloshing. It happens in all vessels, in all tanks. LNG tanks by design, they can't support this. They're not designed to sort of protect themselves against this. And sloshing is a major cause of damage on LNG vessels, particularly if you're not operating them very carefully, or potentially something's gone a little wrong in the commercial operations. And the final one is a favorite of mine, MMBTU. So this is the unit of measure if we're buying and selling cargo normally, and it's the million British thermal units approximately. And it's basically the cargo is sold normally not by quantity, it's sold by energy composition. So you're buying a portion of energy basically. So we would convert the LNG as 1 meter cubed. It's about 24 point something depending on the cargo composition. So as the buyer or the seller, we would sell it as MMBTUs most likely, and we would buy it and trade it in that portion. LNG is, I said to someone just before this presentation, LNG is kind of traditionally a very small protective industry, and a lot of people kind of think perhaps that it's a lot more complicated than it is. LNG ships are the perfect example of how good shipping can and could be. They were designed and built in the kind of late 60s, 70s, a very specific engineering solution to a very specific problem, and that's continued throughout all LNG shipping. And the ships are perfectly designed for the purpose that they were built for, and they operate in a very closed, small industry which has very high operational and commercial standards. And unfortunately, I think it's fair to say quite a lot of shipping segments don't and could learn quite a lot from how LNG operates. The trade-off is the cost. LNG is just expensive industry. And when we're talking about LNG, what we're talking about is this picture's perhaps a little bit outdated these days because of the way the trading has changed. So fundamentally, methane and other components, the LNG, is liquefied in a terminal, although these days it could be an offshore facility. It's loaded onto an LNG tanker. And what I was talking about earlier, normally it would go A to B, back A to B. Those kind of days changed a little while ago now, and it's often traded on a spot cargo, same like any other tanker where the ship doesn't necessarily operate on an A to B shuttle anymore. But fundamentally, the process is the same. We go to a terminal, we discharge, and that LNG, the same for those of you who are here in the UK or in Singapore, is the same. Lots of countries, it's predominantly goes into power plants. It goes into industry in places like China. But obviously more and more these days, particularly in Europe, there's a lot of focus on LNG used in electrical generation, and there's a lot of projects starting up in the continent because of the Russian gas problems. So these are a little old, they're not that old, but I mean, LNG, unfortunately, this pie chart on the left, I don't know why it's squished like that. It refused point blank to become a circle. It comes from the places you would expect, and perhaps a lot of people don't realize Australia is actually the biggest or one of the biggest, depending on when you take the measure, exporters of LNG in the world. This is just LNG, which goes from point A to point B. There's other statistics and things about where it's traded and comes back in, but fundamentally, the exporters is Australia, Qatar, Nigeria, and the cargoes, as you can see, go almost everywhere these days. But the big buyers of LNG still remain to be Asia. So a lot of the vessels do a lot of long voyages. You know, they do Gulf or America to Asia and things like this. The UK, a lot of the gas here comes from Norway or from Russia through the Amal project. So LNG vessel types, and this is one that has changed a little bit over the years as well. There is a lot of different, if we go and ask class what kind of types there are, they have all these different designations of tanks. They have independent tanks and membrane tanks fundamentally. For the purposes of this presentation, I'm only going to talk about two, but there is a reason for that. It's because realistically, the others don't exist in a commercial sense in a wide scope. Independent tanks, when everyone thinks of LNG, they perhaps think of the ship there on the top with the tank domes. These were very popular for a long time and are kind of fallen out of favor these days. But independent tanks are now much more common again because of LNG bunkering. So an independent LNG tank is the same as these tanks on the older kind of Moss type vessels. Predominantly these days, if anyone's talking about an LNG ship, what they mean is a membrane vessel, and that's it there on the bottom with the kind of flat deck. They kind of got a very distinctive flat profile. So membrane vessels, this is what we're talking about. It's very difficult from the outside as non-shipping people perhaps to kind of picture it, but an LNG vessel is basically a container ship, is the best way of thinking of it, only with the containers not there in the holds. And instead of the cargo holds, we have a membrane cargo tank, which is why they have that distinctive shape with the kind of main deck and then the kind of the whaleback kind of deck. That's the top of the cargo tanks kind of protruding out. And if you kind of remove that and pictured it as containers, the hull and everything else would be broadly similar. So this is a membrane tank. Pretty sure most people of these days have seen these kind of pictures because they like people like GTT who make the tanks, the shipyards who build them. They love publishing these shiny pictures from inside the tanks. Membrane tanks, interesting things. They're very, very fragile. They're prone to sloshing damage and they're not self-supporting. So this structure is basically a box which is supported only by the things around it. But the reason they became popular and the reason the other ships basically died away is because membrane tanks are really efficient at what they do. They're very space efficient. They're very, very, very good at insulation these days. The proven designs, I'm sure there's a few people here, and I've spoken over the last few days who perhaps would question that statement a little bit, and proven design. And they're relatively easy to construct these days. And in that picture, what you can see on the bottom is where they're putting the wooden boards down and the equipment is on the wood. That's basically because the floor is so fragile that you can't walk along it. It's you have to support everything, and even if you went inside with a pen in your pocket and dropped it, it would fall straight through the cargo tank. And it happens a lot with that kind of thing in shipyards. The other one is it was a problem in quite a few shipyards in Europe, believe it or not, is people used to go to the toilet in the cargo tank because it's a long way out. It's 30 meters. You have to go back to the jetty. And it was quite common for a while in some shipyards in Europe that they would lift all the wooden boards at the end and then find that there's cargo tank damage because basically it's so fragile. It's not designed to support anything other than LNG. Predominantly, there are other exceptions to this, so apologies for the one or two companies that make this, but basically when we talk about LNG, we talk about GTT, which is Gas Transport Technology. They are the original designers of membrane, and they joined together two companies, which is why they have two different solutions. But fundamentally, GTT is membrane gas vessels. And they have two different types. They have an NO96 membrane, and they have a Mark III, which has a whole raft of like acronyms at the end of it, depending on what kind you would like to buy. Fundamentally, they're a little different. The NO96 is made of two membranes. So it has a primary membrane, which is the internal surface of the tank is where the liquid stays inside. Then it has a big stack of insulation and a second membrane, which is there to help basically contain the cargo. These are all made of something called Invar, which is a special steel which GTT developed, and it's nickel steel. And these tanks are slightly different. They're a little bit, they have their own challenges, but they also slightly less efficient at insulation than the Mark III. But the material itself and the construction method is perhaps a little better in terms of what we're all here today in terms of claims. But as you can see there, it's still very thin, 0.7 millimeters thick. I mean, that's a piece of paper, a piece of tin foil for those in the UK understand what I'm talking about. It's about the same as a piece of tin foil. A Mark III membrane is slightly different. And for you, those of you who are here, and I know there's a couple of people here who I've already heard, this is the one that you all love to hate. So this system is kind of glued together, and the gluing process has been problematic over the past few years. But fundamentally, it's the same. You have an internal membrane, and in this case, made of stainless steel. And then outside it, you have the insulation. And this structures are built inside the cargo holds of the vessels. These days, unfortunately, all LNG ships are pretty much going to be either diesel electric propulsion or another type of engine propulsion. There are still steam ships around. Very few companies have them, and rapidly they're starting to go off to scrap now because the vessels are old. When we talk about diesel electric, we talk about tri-fuel. So when we're talking about tri-fuel, what we mean is the engine can burn fuel oil, it can burn gas oil, and it can burn LNG. So the reason this concept is so great for LNG is because it gives you a lot of flexibility. We have this problem with the cargo where it's boiling off all the time and getting warmer. We have to do something with that gas. We can't vent it to the atmosphere. We don't want to vent to the atmosphere anyway, it's valuable, but also we can't, environmentally, we don't want to do that. So the best solution is something that's flexible. It gives us a nice way of balancing our demands and our power demands and our gas demands together, because we can be a bit flexible by the number of engines we run in based on the speed or the boil off. And fundamentally, it's a great system. It's one that's in use. There's no different from an LNG vessel, diesel electric, to a big cruise vessel that's diesel electric, or a offshore vessel that's diesel electric. They all use exactly the same technology, the same same kind of engines, the same suppliers of equipment for drives and things. It's all very, very similar. So if you go on a cruise vessel, you might well see exactly the same equipment if you went on a big LNG vessel next week. It's also one of the reasons why things like cruise vessels for LNG bunkering is quite a neat solution, because the technology is going back the other way now. The other one, which sort of was kick-started by Nikola and Qatar Gas, was the slow-speed diesel. Everyone is well aware, I'm sure, that slow-speed diesels are very, very efficient machines. They're a great way of propelling ships. And of course, LNG can fuel these kinds of engines as well. It's a more efficient way of using the fuel normally. And what came with this was a slight change in LNG vessel design, where the cargo tanks traditionally had a very low pressure, maybe 0.2, 0.3 of a bar is kind of the maximum limit, depending on design. It brought it up to 0.7, 0.8. So it changes the characteristics of the boil off, because these engines require high pressure gas. There is a new company now, or newish company, that does a low pressure version of the same kind of technology. But yeah, fundamentally, slow speed diesels is a very efficient way of doing it. And you would have the same kind of arrangement electrically with your generators as a diesel electric vessel. Basically, everything is designed to consume the gas as efficiently as possible and waste nothing. So LNG bunkering is something that, for a long time, if I'd have come 5 years ago and made this presentation, everyone would have been talking about LNG bunkering. These days, it doesn't seem to be talked about so much. It's happening. It is happening in Europe. It's happening in Singapore. But it's something that seems to be coming, and we'll talk more about it later. It's there, and it's happening to all kinds of vessels. There's a lot more new build vessels, that can take LNG bunkers, tugs, bulk carriers, VLCCs. There's plenty around now that are being built and delivered or on order that are LNG bunker capable. So it's something that's happening. The other one, which was also very, very popular, was small scale LNG. It's something that is around also. So small scale LNG, basically, as you can see in the picture, there's a traditional LNG carrier on the right, and then a small LNG vessel, which is actually one of my old vessels on the left, which is like 10,000 cubes. It's designed to go in rivers. It's designed to go to small terminals in China. It's designed for a river in Europe. Again, this is one of those things that for a long time was talked about as kind of the future of LNG, and perhaps hasn't really taken off in the way that people expected it to, for whatever reason. But yeah, I mean, it's still there. The ships are still there. They're still being built for special projects and things like that. It doesn't change the fundamentals of the vessels, though. It's just a different kind. The only difference is the smaller vessels would be independent tank, perhaps semi higher pressure compared to the bigger vessels. So a couple of weeks ago, I attended the Decarbonisation Maritime conference in Singapore. And it was quite interesting because not one person spoke about LNG apart from in bad terms. Everyone is focused on the future, quite rightly. And they're talking about the fuel transitions. They're talking about where we're going. And for LNG, it's kind of an odd one. There's solutions. There's things like bio LNG. There's other ways of producing LNG, basically to make it more efficient and make it more environmentally friendly. There's not a lot of information about how this is going to be done or how it's going to transition into this area, I don't think. But it's pretty certain that it's coming and the change will come. It's just not clear how it's going to come in the future. So everyone has quite lofty goals. And part of that is being driven. The new regulations came out this year, which is maybe something perhaps people in here haven't heard of so much, something called CII Index. And this is something that commercially, I think a lot of people, if you're involved with cargo claims or that kind of claim, definitely you're going to see some of this in terms of charter party complaints or charter party issues, because how CII is worked is very controversial. The way they make the maths calculate, it's like all maths, you can pretty much make it say whatever you want. And there were some companies at that conference who were quite clear that, we could use one ship, have a bad CII index on that one vessel, then we swap them over after 6 months, and we end the year with 2 vessels with a good index, which isn't really the intent of the improvement. So yeah, it's something that's coming, and the way that LNG kind of fits into that is that obviously LNG vessels have a very specific mode of operation. And when you put them in a CII index, they actually become incredibly poorly scored and rated because of the way they operate. So they do a lot of potential kind of fast voyages when they're laden because, we've got this cargo that is warming up. We need to get rid of it. We need to get somewhere commercially. We go fast, we discharge it, then we slow steam back a very long distance to the next loading port, and perhaps we wait and things like this. So that's great. It gives you a really good CII index because it's only interested in when you're carrying cargo. What about when we're not carrying cargo? And conversely, if we then slow the vessel down because we don't want to emit so much fuel, we have other problems operationally. So it's going to be a challenge. And yeah, I'm pretty sure that at some point someone will be stood here talking to you guys about CII indexes problems because it's pretty acknowledged that companies don't like it and it's going to be commercially a challenge. So I did do a little bit of Googling to find out about LNG, and there's quite a lot of bad headlines. A lot of people kind of sounding the death knell of LNG as a fuel already, which is odd because a few years ago it was the fuel of the future. The reason they do that is the table on the right there is, this was just recently published by IMO for a few weeks ago as draft legislation. So when we're talking about emission factors under CIO, all fuels now have a rating. And as you can see, actually LNG, which is kind of in the middle of the table there, is a 3, which is almost exactly the same as heavy fuel oil. So you could be kind of forgiven to kind of think, well, why the hell are we using it as a fuel in the first place as an environmental one? And again, it comes down to how they do this, which aspect of the fuel are they measuring? But fundamentally, as you can see, methanol and ethanol, much better. So, you know, realistically, the headlines on the left, is it the future fuel? Doesn't seem like it, but it's pretty clear it's here to stay. And LNG for shore power generation is definitely here to stay for a significant period. So yeah, so it's kind of interesting. The future of LNG is quite interesting. The future of LNG ships could be quite interesting, and what we do with the fuel. So onto the interesting bit, I'm afraid, not so much as in case you're expecting some juicy details. So LNG, as I started with, is a small industry. Even now, with quite a few ships in the world, it's a small industry. And right now, ABL, I did some checking. We have about 4 or 5 open cases. They're all high value. They're all millions of, excluding loss of hire. I have a few which are, I have 2 where the loss of hire is over 20 million. But, you know, I can't tell you any of the details about them. I can't even give you any details about the kind of problems on those cases, because if you are involved with LNG, you probably could identify the company and the vessel almost immediately, or one of your colleagues could, because it's a small world. So often it happens. In fact, Steve called me fairly recently about a job in Europe. I said, oh, I know the guy who's looking after that ship. It's a small world. It's still quite a small connected world. So we're very, very careful when it comes to LNG claims and cases about what we talk about. The reason they're so expensive is the ships themselves are expensive. It's a huge capital investment. The equipment, as soon as you add LNG to anything, it kind of triples the price. Not only because you're only dealing with one supplier who makes it, or 2 suppliers who makes it, but the materials are complex, it's high value parts, and you're putting it into an industry like the offshore oil and gas production industry, where safety is paramount. You're paying for the engineering, basically. The other reason the claims are getting expensive, this chart is a little out of date because I couldn't actually find one that went all the way up to the current date. But I mean, it wasn't so long ago that you're up over $400,000 a day almost for an LNG carrier of a reasonable size as a day rate. So when you're making that kind of money, everything is important. You can't afford to have the ship off hire. You can't afford to stop for a day. And as I said, the ships have high running costs. A typical big LNG carrier, probably $20,000 to $30,000 a day, including the crew. You compare it with a small product tanker that might run around on $5,000 a day. The stakes are different. Everyone's got a vested interest in keeping the ship running. The equipment's high value. The ships, the 180 million there, by the way, is quite outdated. The price just recently I saw was 270 million. The equipment is specialist. The makers who make it, like I said, there's one company in the world who makes the cargo tanks pretty much. So when you need it repaired, you have to give them a call. They can charge you pretty much whatever they want, right? I mean, it's the way the world works. Reputation is a huge thing in LNG. When we think of the companies that run LNG ships, it's who's who of the oil majors. It's who of the ship owners. You know, there's huge, the companies that own these vessels have got billions of dollars invested in them. Reputation is everything, and the industry itself's reputation is important to the people in it. And the final one is reliability. I mean, one of the questions I often get asked is, you see many claims about LNG? Not really, unfortunately, or fortunately, depending on where you're sat in this room, I guess. And it's because the ships are well run, well managed, well maintained by proper companies who invest in them properly, in their and particularly the training. LNG seafarers are pretty much the most expensive ones in the world because of their training, because of their skills, and because of their professionalism. You know, you can't just go out to the market and get someone to come on one of these ships, because even if you did, you go to try and go and load for Shell or BP, they'll reject the ship because you don't have LNG experience. You don't have experience of that vessel type. because they value the experience of the people on board much more so than perhaps other shipping sectors, to make sure that actually nothing ever really goes wrong, which and it works. So we're back at our learning objectives. We'll recap through them, be able to explain the operation, hopefully kind of a vague understanding of how they work. It's obviously much more simple than probably a lot of people thought, despite what LNG industry would have you believe. They're single grade vessels. They load one grade in all their tanks. They might load at different places these days, but fundamentally it's one grade, 4 tanks, and they discharge it somewhere else. They don't do cargo cleaning. They don't do, as long as the ship is operating correctly, there's no real issues with the vessel type. The fundamental differences between the vessel types, yeah, I mean, these days, as I said, realistically, when you talk about LNG, there is only one. It's a membrane carrier. It'll have 1 or 2 types of GTT membrane inside. It'll have 1 or 2 types of propulsion. The vast majority of ships that anyone is going to kind of encounter in the LNG sector will be like this. The understanding the operational constraints, that's perhaps a bit more difficult when you're standing here in a short period of time to kind of explain, but fundamentally the way the ship is built and designed, like we said, is what constrains its operation. And then the final one, the types of claims. Unfortunately, I couldn't give you a lot of details, but fundamentally in terms of claims, cargo tanks, as you probably picked up, is the Achilles heel of these ships. They're incredibly fragile, and when they do go wrong, they're incredibly expensive to fix. A small damage in an LNG tank can easily go a few $1 million depending on the damage. Everything is just the process, as you've seen from the picture, of getting inside the tank is complex. Takes time. It takes a lot of kind of specialist equipment and specialist people. So yeah, those kind of claims are the ones that, you know, quite a few of you in here I've spoken to over the last few days will have encountered. Machinery wise and hollow machinery kind of claims, just generic operational kind of stuff like other vessels, my experience, very few. Very, very, very few. And when it does happen, yes, it's expensive, but in reality, it's the chance of it happening and coming to people like yourselves across your desk is small, because the ships are great and they're, you know, they're well maintained. And fundamentally that's one of the best ways of looking after your ships and reducing the risk, is to keep it operating correctly. So yeah, so come to the next one, which I'm aware is everyone's favorite slide. Is anyone's got any questions online or in the room? Feel free to shout out. Okay.
We've got one question from online.
Okay.
So LNG was only ever going to be a transition fuel. It's clean when burnt, but poisonous when leaked, as it's essentially methane, one of the worst greenhouse gases. When will future fuels be produced at scale?
Yeah, so there was a lot of people in a room a couple of weeks ago for a whole week discussing that, and I don't think anyone has the answer. I mean, LNG is bad, and but it's also bad in terms of a term which I didn't touch on, because, to be honest, trying to explain it in a room like this in 10 minutes is problematic, is methane slip, which is where a lot of the headlines come from. And that's the one where I know there's a report that's been published in the EU somewhere, where some study looked at LNG vessels and proved that they were worse for the environment than not using LNG. But like a lot of these kind of studies, they're focused on one element. So with LNG, what happens is you put the fuel into the engine, and then an element of the fuel remains unburnt, like in all engines, which is methane in this case, which is very greenhouse gas high. And that methane basically passes through the vessel and goes out the funnel. And that's where they're focused on why the fuel is bad. It's very good at other items, but methane slip is a huge problem. And the technology is improving. When it comes to the other part of the question, when the other fuels come in, I don't think anyone knows, basically. Yeah, they're coming. There's a few companies that are doing different vessels, methanol fuel and things, but big scale things, I don't know. It's different subject, I think, different presentation. Okay, so I'll hand over to Cindy now. If I am, yes, sorry, I missed you out. Sorry, go into detail. Generally speaking, we're looking at damages today. Are these stemming from construction damages to construction damages? And then when the construction it's really hard to tell without, I mean, maybe we could talk about more afterwards, but sorry, I'll repeat the question. Yeah, I forgot. Yeah, sorry, I'll repeat that. So the question was basically, are there damages from construction or sloshing or whereabouts? So I think it's very hard to tell. There was a lot of damage claims from sloshing for quite a while, and that was kind of quite a traditional change in terms of the operation pattern. So when I was talking about heel, one of the drivers of that was you'd gone from a more traditional operation where the vessel went from A to B or A to B to C, and it was very easy to say, okay, we've loaded 150,000 cubes. When we get back to where we need to load, basically in order to do that, we keep 10,000 cubes. By the time we get there, most of that will have boiled off. Our tanks are cold, we can load. And then for a while, what was happening was that that didn't become the norm anymore. So people were taking 10,000 cubes a heel, and then just in case, because they might have to go to Australia. But what they'd forgotten is that 10,000 cubes a heel is so all membrane tanks have a sloshing limit, which is a minimum and a maximum, and basically you can't fill in between. And tank design over the years has changed a little bit. So they've developed in area to protect against sloshing. So there was quite a transition period that sloshing was a big problem. Construction problems, yes, because when, for instance, like the new Mark III membrane came out with the glue, they had huge problems. And they had problems in construction, they had problems post-construction with that. But whether one or the other is more prevalent, I would say it's probably, I would say, more construction related, or as much as DTT would never admit it, perhaps it's more of a design issue. There's a lot of cracking that you get in tanks, which is in areas where, I mean, we've seen some, and other companies have as well, where, and GTT have done design changes because they've had cracks in certain areas of high stress that the design originally should have picked up perhaps, but didn't. So you see a lot of those kind of ones, but when it comes to the tank repairs, it's kind of a strange topic because there is an allowable leakage, which if you've ever been involved with tankers, if you can imagine going into a room and saying, can you still insure my tanker? But it's only got a smallest leak, right? I mean, you'd be laughed out of the room. But for LNG, that is how it works. They measure the leak. If it's within what GTT say it's okay, then class will also say it's okay and you can repair it next time. So is that a design issue? Is it a construction issue? It's very difficult to kind of say that, I would say. But yeah, but it's something perhaps we could talk about afterwards as well if you've got more specific questions. Okay, we'll try again. Oh, 2 more. Sorry. Any what? Sorry. Not that I'm aware of. I think so. The question was: is there any anti-sloshing design been studied? I think, as far as I'm aware, no. But basically, because of the tank construction, you would never be able to put something into the middle of those membrane tanks. So one of the reasons why the ships which I showed earlier with the balls, the independent tanks, one of the reasons they were incredibly popular is because that's made of basically this much, like 2 inches thick aluminium. You can run inside the tank and slide down it like a kid if you want. It doesn't do any damage, and those tanks were brilliant because they're totally destruction proof almost. And that's why a lot of vessels that you see have been converted to FSRUs or to floating storage. They use those kind of vessels because you can come and you can load the tanks whatever level you want. There's no loading restrictions at all. But the trade-off was that obviously it's, a sphere is a terrible way of using the space on board the vessel. And the insulation, they couldn't get the insulation, which affects the boil off, which is a big commercial consideration. They couldn't get it to the same standard. And those ships kind of fell by the wayside because of these challenges. But in reality, the tanks themselves is probably a much better solution. And the same with the independent. So the same kind of tanks on those ships. So the tanks that they use, for instance, VLCC that's got LNG bunker tanks basically has those kind of tanks. It's a big gas cylinder, and it's got insulation around the outside, but it's never going to have the same problems as an LNG membrane tank because of its construction. But the trade-off with the membrane is basically, I mean, I read online in terms of like a membrane, you can get down to like 0.7 now is what they're advertising. 0.007% of the cargo per day will boil off. So even 10 years ago, 0.15% was a good day. So, and that change is commercial and it's environmental as well. We don't want the cargo that someone's bought to disappear out of the tanks. And, the best way of doing that is stopping it boil off. So yeah, there's a compromise, but the compromise is driven by the boil off as opposed to the sloshing. Because if you operate it correctly, sloshing is not a problem generally. So I think there was one. Okay. Yeah. Otherwise, yeah.
Okay. Hello, everyone. Glad to see you all again. The purpose of this section of the briefing is simply to keep you up to date of the recent higher cost incidents that ABL have been involved in. And we'd like to show you or remind you that these sorts of incidents and casualties that can happen in shipping and marine operations. But in case you don't know, I'll sort of explain what are these so-called case reports. So the case reports, these feature largely, but not exclusively, hull and machinery casualties with estimated costs of in excess of $250,000, usually excluding salvage costs. They cover only a subset of the total ABL Group caseload, which of course includes many other areas apart from just H&M, typically between 10 to 20% by ABL case numbers. These case reports are also a significant subset of our H&M work, for although they only cover about 20 to 25% of the H&M cases we survey by number, they cover around 65 to 75% of the H&M cases we survey by cost. Treat these with caution though, as estimated costs are often preliminary and subject to further inspections and/or investigations. And in presenting these case reports for the last month of activity, it's not about attributing blame. We just aim to convey what happened, so we won't be giving any definitive conclusions about the cause, as many of these cases are still fresh and it wouldn't be appropriate to do so. And in many cases, the case is still under investigation anyways. So let's start off with some statistics. We've been notified of 16 high-cost cases during April, and the blue columns in this graph show their proportional distribution by casualty type. 6 machinery cases, 2 groundings and steering problem cases, 1 each for contacts and heavy weather, and 4 in the other category, which includes 2 crane failures, 1 case of piracy, and 1 case involving some cargo leakage. As always, with such a small sample set, you're bound to have gaps in the distribution that you see here when you compare it to the distribution for the whole year. In this case, the whole of 2022, given as the gray columns, or 2023. Despite the small sample set and the gaps, even a month's worth of data still reasonably follows what is, year on year, a fairly consistent trend. Now here, we've added in the distribution of the 16 cases by their total costs. Note, we have a spike in the other category, and this is dominated by the piracy case that accounts for about 40% of the total cost for the month, although most of that comes from cargo theft element rather than hull and machinery damages. The total estimated cost for the 16 cases is just over $16 million, and that puts the average cost for April at the 1 million mark, which is spot on the typical annual background figure that we have seen over many years for these higher cost cases. With a third of the year gone, you can see most of the categories are now populated apart from the 3 least common, flooding, ice, and pods. But there are still 8 months to go, and nothing particularly unusual, yet at least, regarding the rate of incidence of the different casualty types. And here we've added the proportions of the cumulative costs. The relative cost of the machinery cases is still high compared to the past, where, as we've said before, we would have expected the red column to be only half to 2/3 the height of the blue column. As we showed last month, the peak in the tail shaft / seal category is a result of a very high cost case involving a tail shaft fracture that we saw in February. And the new peak, now in the other category, comes from the piracy case this month. The average cost for the first third of the year is still a bit lower than expected, coming in at only about $780,000 compared to that long-term observed average of $1 million. But as we said, there's still a lot more of the year to go. Now let's look at the cases in more detail. We've selected only 6 of them if we have time to go through them all. And we'd like you to bear in mind that although we say these are April cases, the month generally refers to when the first advice comes in from our surveyor. Some of the cases, therefore, may actually be from earlier months. First up, we have the Piracy case. This 20-year-old small tanker was operating as a bunkering ship for fishing vessels off the west coast of Africa. She arrived at the rendezvous point for one of the vessels and was drifting with the engine stopped, awaiting its arrival. At 1400 hours, the duty officer observed pirates approaching from the starboard quarter and raised the alarm. The master then raised an alert through the ship's security alert system. Well, at least he thought he did. As it happened, no assistance arrived. No assistance arrived during the 10-year duration of the incident, as far as we know. Anyways, with the engine stopped, they didn't have time to get underway. Plus, they didn't have barbed wire fencing on the railings and bulwarks as other vessels operating in the area often do. Although our surveyor doesn't think this would have made much of a difference. And so the pirates boarded with relative ease, 12 men, fully armed with AK-47s and pistols, wearing dark blue overalls with masks covering their faces. They fired some warning shots into the air, shouting and warning the master to cooperate with them and to not offer any resistance. All crew were taken to the bridge and had their hands tied with cable ties. From there, they were taken to the steering gear room and held there, although given a break later in the mess room due to the unbearable heat. During their captivity, the crew were aware that the ship was sailed by the pirates for about 6 hours and then stopped. It was believed that the pirates were transferring fuel cargo and then to another vessel, possibly 2. Eventually, the crew were locked up again in the steering gear compartment and told that they would be released by someone in due course. And then it all went quiet. After 2.5 hours, conditions were becoming unbearably hot again, and they found that the compartment hadn't been fully secured from the outside, so they were able to get out. The pirates were long gone, but before leaving, they had sabotaged the ship's communications and propulsion systems, presumably to buy some time before the crew could notify the authorities as to what had happened. The crew found that anything that was capable of sending signals was ripped out and either taken or thrown overboard. Here, the AIS system has been removed with the electrical cables cut. This is where the GPS system used to be. And here where the voyage data recorder console once was. Out on deck, the antennas were cut off. This is just more pictures. And even the float-freed voyage data recorder capsule was removed. Our attending surveyor says that much of this damage was unnecessary if they just wanted to disable the ship's communication systems. So although they were able to get the ship moving, perhaps the navigators among the pirates were not that knowledgeable. He says, though, that the sabotage on the engine side was much more precise. Here, we see photos taken by the crew of what they found when they went to the engine room. The engine team got to work to try to get the engine working again, succeeding at last at 1300 hours the next day. They were then able to set sail at slow speed to the nearest port, arriving 2 days later, which is where we saw her in the first pictures. Other damages noted on board were to the mooring ropes, which seem to have been rather carelessly handled by the pirates during their ship-to-ship operations, and damage to the cargo tank hatch cover where they had taken the fuel from. The total cost of repair or replacement to all the ship's items is only about $350,000. But the estimated cost of the stolen cargo, though, is several $1 million. In the next case, we have this 22-year-old Panamax-sized container ship that was also operating off the west coast of Africa. She was underway, having just left port, when a persistent noise started coming from the steering gear room. Initially, the steering of the vessel was not compromised, but later, when they realized they would have to get something done about it, they were on their way to a repair yard in the Mediterranean. They had to switch off the autopilot as it could not cope anymore. Here we see her in dry dock with her steering system being dismantled. The rudder stock has been withdrawn from the rudder and pintles, and the rudder itself is suspended by chains, while it and the various bearing surfaces are examined. The picture is a bit fuzzy, but you could see one shipyard worker inside the upper bearing vacated by the rudder stock, having a close look at the surface of the bearing bush. I understand this was in good order. There were some scratches on the lower pintle bearing bush, however. There was no sign of any damage or paint scraping on the undersides of the hull or the rudder to suggest a grounding while underway, but there were signs of a slight bend in the left end of the rudder, or in the aft end of the rudder, and that plus rudder clearance measurements indicated that some form of disturbance had occurred. Prior to the previous picture, they had the job getting the rudder stock out. They couldn't get the tiller off the top of the rudder stock by normal means, and in the end, they had to cut a hole in the poop deck to lift the combined assembly out into the workshop for more exacting efforts. A special steel rig was constructed which slotted through and gripped the 2 tiller arms, while 2 hydraulic jacks bearing against the top of the rudder stock and the frame attempted to pull the tiller off by pricing action. Apparently, the frame structure distorted the first time they tried this, and they had to stiffen up and try again. And at last, it eventually came free. Here you could see the rudder stock had gone off for tests of its straightness, degree of twist, and the condition of its taper sections and bearings to see if it could be repaired. Unfortunately, the degree of twist and bend meant that a new rudder stock was needed, and the total cost of repair are coming in at over $500,000. In terms of cause, as we said, it doesn't look like a grounding while underway because of the absence of any paint scoring on the bottom of the hull or rudder. Investigations are still very much underway, but rudder movements while the rudder was resting at the seaport perhaps could be one contender. Moving on to the next case, here we have the second highest cost case of 6 engine room machinery damages this month, coming in at about $1.4 million. It involves a small tanker that was only on its 3rd voyage since delivery in January this year when the main engine failed, and the engineers found ominous metallic debris in the sump of the number 1 unit. Impressively, she was still able to get herself to port using the emergency propulsive power with ship generators driving the electrical power takeoff unit on the propeller shafting as a motor. Here we see the cylinder head of the number 1 unit being dismantled. And here we see that what the engines on board first saw, damage to the big end bearing and debris in the sump. Amongst the debris, they found broken bolts that hold the piston crown to the piston skirt. That didn't bode well for what they were going to find in the cylinder. To get to that, though, they had removed the cylinder head, and here they found damage to the rocker arms and the push rods that control the flow of fuel and air into the cylinder. And indeed, when they took the cylinder head off, they found the piston skirt and crown seized in the liner. The Conrad and its big end bearing haven't fared very well either, as you can see here. As you would expect with this sort of casualty, the crankshaft and the number 1 crank pin had suffered some scoring, indenting, and overheating as well. As the ship is still under guarantee, as this will all be fixed as new, and the cause of the engine failure is being properly established. We understand that permanent repairs will include replacing the crankshaft at the next dry docking. In the meantime, in order to keep the ship and the owner's business going, in situ grinding of the number 1 crank pin is carrying it out. As the temporary repairs proceeded, more damages have been found in other units, adding to the cost of both the temporary and permanent repairs. The root cause of all of this is still under investigation, and the engine manufacturer's final report is awaited. We understand that no alarms alerted the crew to any problems prior to the failure. Next up, we have another case involving a ram-type steering gear. This time, the problem seems to have been in the steering gear itself, and unfortunately, this led to a grounding. This 22-year-old Panamax-sized bulk carrier was approaching a Far Eastern port with a pilot on board. At 10 to 8 in the evening, the vessel was happily on a course along the entrance channel at 10 knots when, suddenly, the master reported that the rudder had moved and jammed at 10 degrees to port. Only the number 1 steering gear system was in operation at the time, and the crew say they were unable to get the number 2 backup system in operation before the vessel went aground 5 minutes later. Here, we can see the trajectory of the ship where they must have also reduced engine revs or run the engines astern to slow down as the motion at the end is very erratic. The ship had a slight list following the grounding, but soundings indicated no breaches to the hull. The pilot requested tugs to help her pull off the side of the channel. In the end, 5 assist tugs got her afloat again by 10 to 10 that evening, and she was able to make her way to Anchorage to lick her wounds. A diving survey found no hull damage other than some scratches on the bottom plates below number 1 cargo hold. Recoating will be required in due course, probably at the next dry docking. The more immediate problem of the steering gear failure was traced to the solenoid-controlled valve that controls the hydraulic oil to the different sides of the piston actuators. And if we have a look at the other side of the unit, here we could see the defective unit has been replaced with a spare. In the end, it's not a huge cost, $250,000, but it could have been a lot worse. This 7-year-old general cargo ship was carrying out cargo loading operations in the North American river port when, at 11:30 in the morning, the cable on the ship's number 1 cargo crane broke, causing its cargo grab loaded with 20 tons or so of shredded steel scrap to fall from a height of 25 feet into the transfer hopper barge that was alongside. Here we see the arrangement of the ship and barge and the offending cargo crane. In the left picture, you can just see the cargo grab, which is partially broken through the inner hopper bottom of the very elderly barge. Here on the left is what the grab looks like without its load, and on the right, loaded with 20 tons of scrap. A bluff form, at least, for free falling onto the hopper bottom of the barge, but still a very heavy one. As we will see, the impact, unsurprisingly, heavily dented and tore the 1 inch thick hopper bottom plating and crushed a lot of the stiffening structure in the void space beneath. These distortions caused a penetration of the outer bottom of the barge, leading to water ingress. Fortunately, the available pumps were able to keep up with the ingress until divers were able to apply a temporary patch. Once the outer bottom hole was sealed, they were able to lift grab as we see on the left. The damage to the hopper bottom was not fully visible, though, till they had removed the remaining scrap cargo. As you can see on the left, the general area has been set down and the plating has been sheared through a circular arc of over 90 degrees, matching the footprint of the grab. The base of the grab with its load was probably inclined slightly in this direction and contacted this arc first. For our sake, our surveyor had bravely stuck his arm and his camera through the breach, and you can see the typical crushing and fractures of internals in the void space below the hopper bottom. Within a couple of days, the hopper barge was already on the blocks in a floating dry dock further up the river. The rather disgusting looking thing here that we're looking at is a 6 by 4 inch breach on the outer bottom plating, or rather the rags and underwater curing compound that were pressed around the bits of protruding internals to form a patch. Rather impressively, there doesn't seem to be much, if any, distortion of the outer bottom apart from this tiny hole. The inner bottom and internals appear to have absorbed most of the energy of the falling grab. Investigations are underway into the root cause of the casualty, and detailed inspections of the failed cargo runner are being carried out. The costs given here cover the damages to the ship's crane and grab and for the repairs to the hopper barge, the latter involving the lion's share. And finally, for this month, we have damages to the Suezmax crude oil tanker that was on a laden voyage in the North Atlantic when she encountered very heavy sea conditions. Water ingress to the Boston store somehow occurred, and with the heavy pitching, rolling of the ship, sloshing of the floodwater in the compartment caused several mechanical, structural, and electrical damages. And just to get our bearings, this is roughly where the Boston store is located, right at the front and below the forecastle deck. It is the most uncomfortable location in the ship in terms of absolute and relative motions and impacts from the sea. And by that token, if any water managed to get in there, it is no surprise that it would have got thrown around. Now that we've built this up so much, you're probably expecting terrible devastation in the Boston store. But by the time the ship deviated to the nearest port where our surveyor attended, the crew seemed to have tidied everything up. So the photos are a bit of an anticlimax. Here's a view looking down into the store from the entry level on the main deck. You have to look a bit closely to see the damage. You can see the electrical cabinets have been affected. We understand the markings on the sides of the compartment indicate that the water level in here was about 1.6 meters. That's above the level of the taller cabinet. Imagine that amount of water sloshing around. Here we can see the main stairway has been washed away. Some of the scrap that the crew have collected. And here are close-ups of the electrical cabinets that we saw earlier. These are rather important as they serve all the fore-end mooring and anchoring equipment. Here we see the footprint of where a large hydraulic unit once stood before it was broken off its mounts. And this is no small piece of kit. Here's a view of a similar one located in the steering compartment. Out on deck, additional damages were found, but no one was allowed to take photos as the vessel had cargo on board. We understand the starboard embarkment ladder was washed away, that bulwarks were deformed, and that one of the starboard anchor flukes was bent. Back in the Boston store, lots of the piping systems and valves have suffered from water impact and mechanical contact damage and need to be repaired or replaced. And here's where some degree of uncertainty arises to where the floodwater came from in the first place. Was it through a leak, fracture in the pipeline, what have you? Or was it from the starboard chain locker that has several openings in the Boston store? This was also found to have flooded, possibly via the anchor hose pipe from the heavy seas. Investigations are still underway in this respect, and all we know with reasonable clarity at this point that the costs to put all of this right are likely to be just above the $1 million mark. That's all we have time for this month. I'm going to hand it back to Jason now.
Thank you to both our technical presenters. That was very interesting. And thank you for everyone here and online for joining us for today's presentations. I hope you enjoyed it. Now to a pleasurable bit, I hope for at least for one person anyway. We do have a monthly draw, and we have a winner for our prize draw. And the winner this month is Ivan Banovsky. Ivan, are you present in the room? Then I'll get to drink it myself, is that right? Oh no, sorry. No, we hold on to it and we will make sure it gets to Ivan afterwards. We are actually taking a short break from the market briefing. There'll be no presentation in June, but please do join us again for our next briefing, which is on Thursday, the 13th of July, 9:30 to 10:30, here at the old library, and of course, online for yourselves joining us there. Do watch out on our website. We'll give you on social media, but more details will follow. If you do want a chance to take part in the next prize draw, make sure you do send across your answers to this month's question that you will find up in our follow-up email. Without that, thank you very much for joining us here, and thank you online. Thank you.